Hi all. Question. Let's read the question now. A capacitor C1 is charged to a potential V1 is connected to another capacitor C2 charged to a potential V2. What I asked to find out? First part, final potential of each capacitor. Second part, final charge on each capacitor. And third part, loss in potential energy in the process. Try for a minute by pausing the video. Okay. Now write this question in your book. So try to solve it by yourself and then listen to my solution. Okay, let me take the first part. The first one important thing I have to say is that it is not told how the plates are connected. Let me take the first orientation. In the first orientation, I am connecting in such a way that the positive plate of C1 is connected to positive plate of C2. And negative plate of C1 is connected to negative plate of C2. This arrangement is called parallel connection. Parallel connection of capacitors is what this arrangement is called. Parallel connection. Okay, let us suppose that the charge on this capacitor is Q1, charge on this capacitor is Q2. Now Q1 is equal to C1V1, Q2 is equal to C2V2, which means initial charge on the system is C1V1 plus C2V2. We require it for later applications. Let us keep this as equation number 1. Another question, what will happen? Capacitors will share their charges until they attain same potential, right? Another question, from where to where? Suppose that if Q1 is greater than Q2, from where to where these charges flow? If Q1 is greater than Q2, from where to where these charges will flow? This is an important question. I repeat, if Q1 is greater than Q2, from where to where these charges will flow? From where to where these charges will flow? Everyone will say that charge will flow from C1 to C2 because Q1 is greater than Q2, right? Q1 is greater than Q2, so charges will flow from C1 to C2. Let me tell you, this is a big blunder. This is a big blunder, and your answer will be absolutely wrong. The flow of charges does not depend on the charge on each capacitor, but it depends on which capacitor is at a greater potential. The flow of charges from one capacitor to another does not depend on the charge on each capacitor, but it depends on the potential of the capacitor. Which capacitor is at a greater potential, that is what matters. Let us have an analog of the same situation. Okay. Let me consider a tank at the ground, and let me consider another tank at a height. This tank has got a liquid level, say it has got a volume V1. The level of water in the second tank is V2. The second tank is located at a height, say this is over a platform, over a basement where it is placed. Now tell me, which tank has greater amount of water? Surely this is tank, okay, tank 1 surely has got greater amount of water, right? I'm not using the help of any external agencies like a pump set. I'm just saying, okay, suppose that if I if I just connect these two by means of a pipe is put likewise. Okay, from where to where this water will flow? From where to where the water will flow? Tank 1 to tank 2 or tank 2 to tank 1? That's a question I want you to get me the answer to. എവിടെ നിന്നോട്ട് വെള്ളം പോകും? 1-ൽ നിന്ന് 2-ലേക്ക് പോകുമോ അതോ 2-ൽ നിന്ന് 1-ലേക്ക് വരുമോ? നിങ്ങളുടെ ഉത്തരം എന്താ? 2-ൽ വെള്ളം കുറവാണ്. 2-ന്റെ അടിയിലാണ് ഞാൻ പൈപ്പ് കണക്ട് ചെയ്തേക്കുന്നത്. 2-ൽ നിന്നും 1-ലേക്ക് വരുമോ അതോ 1-ൽ നിന്ന് 2-ലേക്ക് പോകുമോ? ഏതിലാണ് കൂടുതൽ വെള്ളമുള്ളത്? ഉറപ്പായിട്ടും പറയാൻ 1-ലാണ് വെള്ളമുള്ളത്. പക്ഷെ വെള്ളം ഇവിടുന്ന് എങ്ങോട്ടാ ഫ്ലോ ചെയ്യുക? 2-ൽ നിന്നും 1-ലേക്ക് ഫ്ലോ ചെയ്യും. എന്തുകൊണ്ട് 2-ൽ നിന്നും 1-ലേക്ക് വെള്ളം പോരുന്നു? ബിക്കോസ് ടാങ്ക് 2 ആണ് ഹൈറ്റിലിരിക്കുന്നത്. അപ്പൊ വെള്ളത്തിന്റെ ഔട്ട്ഫ്ലോ എന്തിനെ ഡിപ്പെൻഡ് ചെയ്യുന്നു? ഇതിനകത്തുള്ള വെള്ളത്തിന്റെ അളവിനെ ഡിപ്പെൻഡ് ചെയ്യുന്നു അതോ ഹൈറ്റിനെ ഡിപ്പെൻഡ് ചെയ്യുന്നു? Clearly say it depends on the height where the tank is located. It does not depend. Height will increase its potential. ശരിയല്ലേ മക്കളെ? ഹൈറ്റ് കൂടുതലാണെങ്കിൽ ഗ്രാവിറ്റേഷണൽ പൊട്ടൻഷ്യൽ കൂടുതലാണെന്ന് നമ്മൾ പഠിച്ചിട്ടുണ്ട്. അപ്പോൾ ഇവിടുത്തെ വാട്ടർ ഫ്ലോ എന്തിനെ ഡിപ്പെൻഡ് ചെയ്യുന്നു? ഗ്രാവിറ്റേഷണൽ പൊട്ടൻഷ്യലിനെ ഡിപ്പെൻഡ് ചെയ്യുന്നു. എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ വാട്ടർ വിൽ ഓൾവേസ് ഫ്ലോ ഫ്രം ഹയർ പൊട്ടൻഷ്യൽ ടു ലോവർ പൊട്ടൻഷ്യൽ. ശരിയല്ലേ? വെള്ളം എപ്പോഴും ഹയർ പൊട്ടൻഷ്യലിൽ നിന്ന് ലോവർ പൊട്ടൻഷ്യലിലേക്ക് വീഴുന്നത്. ലോവർ പൊട്ടൻഷ്യലിൽ ഇരിക്കുന്ന ടാങ്കിൽ എന്ത് വെള്ളം ഉണ്ടെന്നുള്ള ഇവിടുത്തെ മാറ്റർ അല്ല. Then what matters is which is at a greater potential. ശരിയല്ലേ? മനസ്സിലായോ? അപ്പൊ എനിക്ക് ഇതേ ആശയം തന്നെ ഇവിടെ ഉപയോഗിക്കാം. അപ്പൊ എനിക്കിവിടെ പറയാനുള്ള കാര്യം എന്ന് പറഞ്ഞാൽ ഏത് കപ്പാസിറ്ററിലാണോ ചാർജ് കൂടുതൽ എന്നുള്ള എനിക്ക് മാറ്റർ അല്ല. ഏത് കപ്പാസിറ്റർ ആണോ ഗ്രേറ്റർ പൊട്ടൻഷ്യൽ അതാണ് എന്നെ സംബന്ധിച്ചിടത്തോളം മാറ്റർ ഓഫ് കൺസേൺ. അപ്പൊ നിങ്ങൾ ഓട്ടോമാറ്റിക് ആയിട്ട് ചോദിക്കും, സാറേ Q1 ഗ്രേറ്റർ ദാൻ Q2 എന്ന് പറയുമ്പോൾ ഇതിന്റെ പൊട്ടൻഷ്യൽ അല്ലേ കൂടുതൽ വരിക? നിർബന്ധമില്ല. ബിക്കോസ് പൊട്ടൻഷ്യൽ V is equal to Q by C. Potential depends not only on charge but also on capacitor. The capacitance of the capacitor. Which means greater the capacitance, greater the charge, Q by C can still be less than, Q by C of first capacitor can be less than Q by C of the second capacitor. Just ഒരു എക്സാമ്പിൾ പറഞ്ഞാൽ ഞാൻ Q1-നെ 2 മൈക്രോകൂളും എടുത്തു, Q2-നെ 1 മൈക്രോകൂളും എടുത്തു, C1-നെ ഞാൻ 2 മൈക്രോഫാരഡ് എടുത്തു, C2-നെ 0.5 മൈക്രോഫാരഡ് എടുത്തു. Now you can see that Q1 is greater than Q2, C1 is greater than C2. Now we can see that V1 is equal to how much? Q1 divided by C1, which is equal to 1 volt. And V2 is equal to Q2 divided by C2, that is 2 volt. So in this case, charges will flow from which capacitor to which capacitor? From 2 to 1, right? Charges will flow from capacitor C2 to capacitor C1, although charge on C2 is less than charge on C1. So the flow of charges primarily depends on, the flow of charge between two capacitors primarily depends on the potential difference of the capacitor, right? So please bear that point in your mind. The flow of charges between capacitors depends on the potential difference between the plates of the capacitor. And how long the charge flow will take place? How long? The charge flow will take place until both capacitors attain same, charge is wrong, but same potential. I repeat, the charge exchange between capacitors will take place until both capacitors attain same potential. Charge flow between capacitors take place until both attain same potential. This is Qi. Now finally, once charge transfer take place, once charge transfer takes place, capacitors will attain a common potential, right? Capacitors will attain a common potential, and at that point the charge flow will stop. Which means the final charge on the first capacitor will be equal to C1V, and final charge on the second capacitor is equal to C2V, which means final charge on the system will be equal to C1V plus C2V. Final charge on the system will be equal to C1V plus C2V, which is equal to C1 plus C2 into V. That is equation number 2. Now our first question is to find out final potential of each capacitor, right? Final potential of each capacitor, now we can use the conservation of charge, which implies from conservation of charge, Qi is equal to Qf, which means you can see C1 V1 plus C2 V2 is equal to C1 plus C2 into V. This will give you what is V equal to. You can get the answer. Qi is equal to Q of C1 V1 is plus C2 V2 is equal to C1 plus C2 into V. That will give you V is equal to what? C1 V1 plus C2 V2 divided by C1 plus C2. This is the answer I am getting when the positive and positive plates are connected together, negative and negative plates are connected together. This is the expression for the potential V. C1 V1 plus C2 V2 divided by C1 plus C2. This is first part of the question. Now second part of the question is final charge on each capacitor. Now it's very simple. That I leave to you only. Final charge on each capacitor, Q1 final is equal to C1V, Q2 final is equal to C2V. I got the value of V. You can easily find out Q1F and Q2F. That I leave to you. The final charge on each capacitor. Q1F is equal to C1V, Q2F is equal to C2V. You got V here. You can easily find out the value of final charge on each capacitor. That is your job now. What is the next part? So please copy down this in your notebook. This is very, very important. The next part is here to find out the loss of energy, right? What is initial energy of the system? Initial energy of the system. Initial energy is equal to half C1 V1 square. That is the energy of a parallel plate capacitor. This is the energy on the first capacitor. Half C2 V2 square. This is the initial energy on the system. Now final energy on the system is equal to what going to be? Final potential on each capacitor is V. Final potential on each capacitor is C. So energy on the first capacitor will be half C1 V square plus half C2 V square. Then what is the loss of energy? If delta U represents the loss of energy, this will be equal to Ui minus Uf. The loss of energy is equal to Ui minus Uf. You can substitute for V from this expression and you can take the difference, then you will get the answer. Okay. Now may I just wipe off this side. This will solve to get the answer. You need to study only the final result. You can substitute for V and simplify, or otherwise I will just write this is half into C1 plus C2 into V square. This also will satisfy your needs. This can be solved to get the answer as half into C1 C2 divided by C1 plus C2 into V1 minus V2 the whole square. This is the loss of potential energy in the process. Half C1 C2 divided by C1 plus C2 into V1 minus V2 the whole square. You have learned a similar expression in first year with the chapter work energy and power, where we studied about the loss of mechanical energy in a perfectly inelastic equation. The procedure looks exactly the same. This answer we get. Delta U is equal to half C1 C2 divided by C1 plus C2 into V1 minus V2 the whole square. This is the answer. Now we can see that if V1, what is V1? V1 is the initial potential of capacitor C1. V2 is the initial potential of capacitor C2. If V1 is equal to V2, see, initial potentials of both capacitors are same. What does that mean? There will be neither exchange of charge between the plates. Why? Because already they are at the same potential. Already these two are at the same potential. In that case, there is no loss of energy. Delta U is equal to 0. There is no loss of energy because V1 is equal to V2. Now, second question which you generally find, a charged capacitor connected with an uncharged capacitor. A charged capacitor connected with an uncharged capacitor. Now what does that mean here? Charged capacitor connected with an uncharged capacitor. Which means V1 not equal to 0 and V2 is equal to 0. Uncharged capacitor means there is no charge or there is no potential difference between the plates. Uncharged. The meaning of the word uncharged is that there is no potential difference. So V1 not equal to 0 and V2 is equal to 0. In this case, what is the final potential? We have the formula of final potential is C1 V1 plus C2 V2 divided by C1 plus C2. Now V2 is equal to 0. V2 is equal to 0, which will give you C1 V1 divided by C1 plus C2. This is the expression for final potential. And what is this is very, very important. I tell you, this is the answer we're getting. And what is the expression for the loss in potential energy? Loss in electrostatic potential energy. So now we got V2 is equal to 0. In this case, your answer will be half into C1 C2 divided by C1 plus C2 into V1 square. Why? Because V2 is equal to 0. This is the loss of potential energy in the process. Hope it is clear to you. Loss in potential energy in the process is this one. So please understand these equations carefully. Now let me discuss a situation where the same has been asked in a board examination paper. May I wipe it off? Wipe off the board, please. The same question has been asked in a board examination paper. Also with entrance, it's a very important topic, I tell you. The question was likewise. They have given a figure. The potential is V. There is a switch here. Let us call it as S1. This capacitor is C1 or rather C. Let us take it as C1. And there was another switch S2. This is connected to a capacitor C2. In the question of board examination, they are given similar capacitors, capacitance of same value. But I take different values because this will generalize this kind of problems. The question says initially S1 is closed for sufficiently a long time Now S1 is open and S2 is closed. What is the final potential charge on each capacitor? I don't remember exactly what is in the question, but this is somehow the question is all about. What is the final charge on the each capacitor? This is a question. What does that mean? Initially S1 is closed. Let me take this figure. S1 is closed for a long time. That means the circuit. We have to understand the circuit properly. V. This is C1. I need not draw C2 because the switch is open. Initially S1 is closed and S2 is open. That also should be included in the question. I'm sorry. Now what will happen? As S1 is closed, C1 will charge to a potential V because it is closed for sufficiently long time. Which means the charge on capacitor C1 is equal to, and C2 is uncharged also because S2 is open. C2 is uncharged whereas C1 is charged. So Q1 is equal to C1V. Q1 will charge to a potential V, right? And similarly the energy on capacitor 1 is half C1V square. Okay, now what happens? Now S1 is open. S1 is open. Here S1 closed, S2 open. I hope you can see here, or rather I write here. Q1 is equal to C1V and potential energy U1 is equal to half C1V square, right? Then what happens? This is the situation when S1 closed and S2 open. Now S1 is open and S2 closed. S1 is open. S1 is open. Now I need not draw this side. Why? Because it's a part of an open circuit. In this case, what will be the circuit is all about? This is C1. This is C2. Now these two forms a capacitor. This is a positive plate of C1. This is the negative plate of C2. Now this is uncharged means this is zero potential. This is at a potential V because it is charged to this potential. Right? Which means charges will flow from C1 to C2. Right? Charges will flow from C1 to C2 until they attain common potential. Let me consider Vc as the common potential. If Vc is the common potential, I can say this is equal to C1V divided by C1 plus C2 because a charged capacitor connected to an uncharged capacitor. That is a situation you can see here. A charged capacitor is connected to an uncharged capacitor, as you can see here. Vc is equal to C1V divided by C1 plus C2. That is a common potential and the problem is over here. And in this case, the loss of energy delta U is equal to, if you are asked to find out the loss of energy delta U, this is equal to half into C1 C2 divided by C1 plus C2 into V square. That's the loss of energy. And final potential energy on the system will be equal to half C1 plus C2 into V square. So what all things you require here, I have calculated everything. I hope this is clear to you. In the first part of the discussion, we have considered that positive plate of capacitor C1 is connected to the positive plate of the capacitor C2. Now in this discussion, we are going to take the second orientation is called series connection. In series connection, what we do is that, okay, this is capacitor C1, this is capacitor C2. The positive plate of C1 is connected to the negative plate of C2. The negative plate of C1 is connected to the positive plate, negative plate is connected to the positive plate of C2. This is C1, this is C2. In this case, the initial charge on the system is equal to C1 V1. Last case, when we arranged the positive and positive plates, we took it as C1 V1 plus C2 V2. Now the plates are, the polarities of the plates are interchanged. So what is this going to be? This is C1 V1 minus C2 V2. Qi is equal to C1 V1 minus C2 V2. Then what will happen, as we stated earlier, charges will flow between plates until they attain same potential. Which means final potential of the system will be equal to C1 plus C2 into V. Equating these two equations, we will get V is equal to initial, from the conservation of charge, Qi is equal to Qf. From the conservation of charge, Qi is equal to Qf, which implies C1 V1 minus C2 V2 is equal to C1 plus C2 into V. Or common potential in this case is going to be C1 V1. Last case we got plus. Now that V2 should be replaced with minus V2, then you will arrive at this answer. C2 V2 divided by C1 plus C2. This is the common potential of the system. Then initial energy of the system was half C1 V1 square plus half C2 V2 square. Don't take minus here because this is minus V2. The square of minus V2 is going to be plus V2 square. Then what is the final energy of the system going to be? Half into C1 plus C2 into V square. This is the final potential energy of the system. This is the initial potential energy system. Now we can easily calculate the loss in potential energy as half C1 C2 by C1 plus C2. What was the result we got earlier? V1 minus V2 the whole square. Here that V2 should be replaced with another minus V2. So this case the answer is going to be V1 plus V2 the whole square. So since the calculation is very lengthy, I am not using here. The answer is of C1 C2 divided by what? C1 plus C2 into V1 plus V2 the whole square. This is the loss of electrostatic potential energy when the capacitor plates are connected in series. So please understand the two combinations, series combination and parallel combination. Now the question comes, how do we identify whether the combination is series or parallel? Very simple. When two capacitors are arranged in such a way that the positive plates of the capacitors are connected together, it is parallel connection. Positive plates of both capacitors are connected together means parallel connection. Negative plates of the two capacitors, positive plates are connected together, negative plates of the capacitors are connected together, they are called a parallel connection. Then what about series connection? Positive plate of one capacitor is connected to the negative plate of the second capacitor, then this connection is called a parallel connection. What is the difference between series and parallel connection? I think I made mistake, I'm sorry. In series connection, positive plate of one capacitor is connected to the negative plate of the other. In parallel connection, positive plate of the first capacitor is connected to the positive plate of the second capacitor. Negative plate of the first capacitor is connected to the negative plate of the second one. I hope it is clear. I will just say once more. I don't know how I made a confusion in between. In series connection, positive plate of the first capacitor is connected to the negative plate of the other and vice versa. In parallel connection, positive plates of both the capacitors are connected together, negative plates of both the capacitors are connected together. Now see, this is series connection. positive and negative connected together. In parallel connection, what we do, this is positive plate of first capacitor, this is positive plate of second capacitor, this is negative plate of first capacitor, this is negative plate of second capacitor. So understand between series connection and parallel connection. Hope it is clear to you. Thank you.